Hello, Assalamu alaikum. How are you all?
Walaikum assalam.
All good? Okay, do we have any questions from previous sessions? Regarding limiting reactants, excess reactants, or anything else? No questions? Okay, let's begin with today's session. We're going to discuss and basically try to complete most of the leftover topic that is regarding the mole concept. I think I told you something about the concentration as well in the last session. What is concentration? Concentration is basically when any solute, any amount of solute or a specific known amount of solute dissolves in a particular solvent. And the solute can be either, it can be either the mass of the solute which is known to you, or it can be either the number of moles of solute which is known to you. So grams or moles of the solute, which is basically the substance which gets dissolved into the liquid, and that liquid is going to be your solvent. So the volume of the solvent is known, and the number of moles or the mass of the solute is known to you. So that amount of moles, or amount of that solute per unit volume of that solution is referred to as concentration. Okay. So basically, C is equals to mass upon volume, and your volume could either be in decimeter cube or it could be in centimeter cube. However, the standard units of concentration which are used are grams per decimeter cube and moles per decimeter cube. So it is basically N upon V. Okay. Even if you look into the units which are given to you, you can simply derive your own formula, right? If you look into the units, your this units basically say or refer to, this is mass divided by the decimeter cube, which means mass upon volume, right? Similarly, here it is moles per decimeter cube, which means moles upon volume. So concentration is basically C is equals to N upon V, or you can rearrange it to according to your needs, whatever is asked in the question paper. For instance, if number of moles is asked, then what are you going to do? You will multiply concentration times volume. Okay. Next. So yes, a solution or the mixture which is formed when a solute dissolves in a solvent, that is the amount of or the volume of a solution measured is either in centimeter cube or decimeter cube, and the solute is either in grams or it is in moles. Okay, the concentration refers to the amount of solute that there is in the specific volume of the solvent, and the greater the amount of solute in a given volume, obviously greater would be the concentration of it. Okay. If I say that, for instance, if the amount of moles is increasing and the volume remains constant, okay, obviously the concentration is going to increase as a result. Okay. Is this point clear so far? Is this point clear so far?
Yes.
Okay. Now, as we've discussed that the concentration is mass upon volume, which is grams per decimeter cube. And this volume which is given to you, it could either be in centimeter cube. If it is in centimeter cube, then you have to convert it into decimeter cube. Centimeter cube is a smaller unit. When you go to decimeter cube, it is a bigger unit. So you divide it by 1,000. Okay, so 1 decimeter cube is basically equivalent to 1,000 centimeter cube. Whereas if you convert, or if you have to convert decimeter cube into centimeter cube, you would be multiplying it by 1,000. All right, and this conversion is necessary to get the accurate answer. Okay, if conversion or if concentration is basically asked to be calculated using the mass, you will, and concentration there that is required is in grams per decimeter cube, then it should be mass of the solute divided by the volume of the solution, and this is in grams per decimeter cube. Is this point clear so far? Yes, is this point clear so far?
Yes, miss.
Okay. Let's move on to the next one. All right. So look at this question here. The question says that a student dissolved 10 grams of sodium hydroxide in 2 decimeter cube of distilled water. Calculate the concentration of the solution in grams per decimeter cube. Okay. Okay. So what are you going to do here? Concentration is equals to mass which is given to you. The mass is 10 grams of sodium hydroxide. This is the solute, okay? And your solvent is distilled water. The volume is known to you. It is 2 decimeter cube. Also, if you look into the unit which is given to you, this refers to that the concentration has to be found out in grams per decimeter cube. This means that you really don't need to convert any of these units. Okay, so 10 will be divided by 2 to give you the final answer, that is 5 grams per decimeter cube for the concentration. Is this clear?
Yes, miss.
Okay, look at another one. This question here says that the concentration of solution of sodium hydroxide in moles per decimeter cube has to be calculated, where mass is given to you and the volume is given to you of the solvent. The volume is in centimeter cube, whereas the concentration which has to be found out is basically in moles per decimeter cube. This means that the formula that you will be using here is C is equals to N upon V, right? Now you don't have the number of moles. You have to convert the number of moles. How are you going to find out the number of moles? Does anyone remember the formula? Moles is equal to mass times molar mass. What is the mass? It is 80. Will be multiplied by the molar mass, which is, yes.
Yes, it is divided, not multiplied.
What is divided?
Mass over molar.
Mass over molar mass. Yes. Okay. Sorry. What will be the molar mass for sodium hydroxide? It should be 23 plus 16 plus 1. The relative atomic masses, they have to be added to find out the relative molecular mass of the substance. What will be the final answer? 40? Yes. Don't you have calculators? This will be the number of moles, mass upon molar mass divided by volume. What is the volume? In decimeter cube. You have to convert 500 centimeter cube into decimeter cube. What will we do? 500 will be divided by 1000 to convert it into decimeter cube. Okay. What is the final answer?
4.
Okay, 4 is the final answer. Wait, I added Ahmed. Why didn't he join? Ahmed, are you around? He's here? Okay, okay.
Yes.
Yes. So the answer is going to be 4.0 moles per decimetric cube, right? Moving on to the next one. Look at this one. You have 25 centimeter cube, a known volume and a known concentration of sodium carbonate, which is completely neutralized by 20 centimeter cube of dilute hydrochloric acid. So the acid's volume is known to you. Calculate the concentration and moles per decimeter cube of hydrochloric acid. You have to find out the concentration of hydrochloric acid in moles per decimeter cube. What is already given to you? You have been given the volume and you have been given the concentration, okay, of sodium carbonate. This means you can find out the number of moles of sodium carbonate. And by using this number of moles, you can find out the actual number of moles it will be, or it shall be reacting with hydrochloric acid. By using the amount of moles of hydrochloric acid, which you have found out, then you're going to find out the actual concentration, which is going to be N upon V. V is given to you for hydrochloric acid, which is 20 centimeter cube. And you must look into the convergence as well from centimeter cube into decimeter cube. Okay. So moles of sodium carbonate will be C into V. What is the concentration? It is 0.05. What is the volume? 25. Anything else which we need to do here?
Divide by 1,000.
Yes, we have to convert it into decimeter cube by dividing it by 1,000. Okay. So we're going to do this, and then when we find it out, what is the amount of moles of sodium carbonate?
It's 1.25 times 10 power minus 3.
Okay, 1.25 10 times 10 to the power of minus 2, which means 0.00125 moles. Okay. So when you look into this, this is the actual amount of moles that have been completely neutralized by the amount of hydrochloric acid. The next step is that you should look into the chemically balanced equation and the stoichiometric ratios, the molar ratios which are given to you in this equation. If you look into this one, 1 mole of sodium carbonate basically reacts with 2 moles of hydrochloric acid. Okay, so the molar ratio tends to be 1:2. Okay, the molar ratio between these two reactants will become 1:2. This means 1 moles of sodium carbonate reacts with 2 moles of hydrochloric acid. So if 0.00125 moles are already given to you, how much could be the amount of moles of hydrochloric acid? We're going to put an X here, okay? Place an X here and then cross multiply this. So this means 2 times 0.00125 will give you the amount of moles of hydrochloric acid. So it is 2 times 0.00125, which is going to be
0.0025.
0.0025. So 0.0025 are the actual number of moles of hydrochloric acid which have reacted with sodium carbonate. Now, using this amount of moles, you will place it or place all the values here in this formula, that is C is equals to N upon V. Volume is 20 centimeter cube. This has to be converted into decimeter cube by dividing it by 1,000, and then you will get the final answer for the concentration. Is this point clear? Tell me the final answer here for concentration.
0.125.
0.125. Okay, that's it. 0.125, and the units will be moles per decimeter cube. Okay. Moving on to the next one. Now you have a solution of 25 centimeter cube of hydrochloric acid, which is titrated against a solution of 0.1 moles of sodium hydroxide. 12.1 centimeter cube of sodium hydroxide was required for a complete reaction to take place. Determine the concentration of the acid. Now, I will give you some time to solve this, okay? Review this question and then let me know the final answer. Write your answers in the chat box. For this one, you will have to write down a chemically balanced equation and then continue forward. Have you all solved? Does anyone have any difficulties up till yet? Yes, Ayla, Ahmed, Abdullah, Ishal, Ibrahim, Ryan.
Miss, I don't understand how to do the question.
Okay, what comes to your mind when you look at this question? First things first, you must have a balanced chemical equation, right? Now, this reaction here is basically this is an acid-alkali base titration reaction. So this means that you are going to write hydrochloric acid, which reacts with sodium hydroxide, which is NaOH. And if you remember the general equation for acid-base titration, the resultant products, they are salt and water. If you remember, salt is basically, I haven't taught this topic yet, but when we were doing chemical formula, I told you that salt is formed when hydrogen is displaced in the acid by a metal. So sodium will displace since this is a metal, and sodium NaCl will be formed. And the byproduct is going to be water. Okay, then you're going to look into whether this equation is chemically balanced or not. Is this balanced? Yes, Diane, is this balanced?
Uh, yes.
Yes, okay. Now, when we know that this is a chemically balanced equation, now we can move on forward with our molar calculation. What do we have already? We have to find out the concentration of the acid. This means that the other reactants data must be given to us, and that is sodium hydroxide. The volume is given to you and the concentration is given to you. By using the concentration and the volume, you can find out the moles of sodium hydroxide. Okay. So concentration is 0.1. You are going to multiply 0.1 times the volume. The volume of sodium hydroxide is 12.1 centimeter cube. This means that you must be dividing it by 1000 to convert it into decimeter cube, right? Why is this necessary? Since your concentration was also in moles per decimeter cube, so you need to convert the centimeter into decimeter cube as well. Is this point clear so far?
Yes, yes.
How much of the amount of moles is present? 0.1 times 12.1 divided by 1000 is?
0.001 to 1.
0.00121. Okay. So this is the amount of moles of sodium hydroxide which is present. Now, since I need to find out the concentration of hydrochloric acid, this means that I must have the other two variables as well. Okay. I must know the amount of moles of hydrochloric acid, and I must also know the volume of hydrochloric acid. Now, I have been given the volume of hydrochloric acid, that is 25 centimeter cube, but I haven't been given the amount of moles. But by using this amount of moles of sodium hydroxide, I can find out the amount of moles of hydrochloric acid. How? The molar ratio says that one ratio of 1 moles of hydrochloric acid reacts with 1 moles of sodium hydroxide. When no number is written adjacent to this chemical formula or chemical symbols, this means that it is 1. Okay. But for instance, if any other number is written, this means supposing if 2 was written here, then this means that 2 moles of hydrochloric acid react with 1 mole. So the molar ratio would become 2:1. Since here 1:1 is the molar ratio, okay. So you will use this. This means that equal amount of moles are formed. This means that the amount of moles of hydrochloric acid which is produced is also 0.00121. It's exactly the same amount as sodium hydroxide. Okay. You will put this value, place this value in the formula 0.001 divided by volume. Now, this volume has to be converted into decimeter cube since this is in centimeter cube. Okay. And why is that so? Because we need to find out the concentration in moles per decimeter cube. Okay. Which is the standard. So it is going to be 25 divided by, since it is in centimeter cube, so 25 divided by 1000 to convert it into decimeter cube. And then you will get the final answer for concentration, which is as mentioned by Fahad and Zoya. Both of their answers are correct, 0.048 moles per decimeter cube. Okay. Is this point clear? Are we clear now? Do we have any queries? Yes, Ryan, Ibrahim, Ishal, Ahmad, Ayla, Abdullah.
No, miss, no questions.
Okay, moving on to the next one. So you have been given the reaction equation here. 25 centimeter cube of 0.15 moles per decimeter cube barium hydroxide was required to neutralize a known volume of nitric acid during a titration. Calculate the concentration of nitric acid that was used. Give your answer to 2 decimal places. Do this, solve this one, and then let me know what is your answer. Write your answers in the chat box. Usually the chemical equations, they are given to you in the paper. However, if they aren't given to you, then you have to formulate a chemical equation, a simple chemical equation, which should be chemically balanced. And this is also an acid-base titration reaction. So the reactant products you see here are the salt, barium nitrate, which is formed, and water, which is produced as a byproduct. Can someone tell me the molar ratio between the reactants here, according to the stoichiometric equation? Yes, Ryan. What do you think is the molar ratio between the reactants here, barium hydroxide and nitric acid?
Miss, what's the molar ratio?
Molar ratio is the ratio amongst the, for instance, two different substances. They could be either reactants or reactants and products. They're reacting moles.
I'm not sure.
Okay, tell me what coefficients are written with the reactants, with barium hydroxide and with nitric acid?
Aqueous?
No, coefficients.
Oh.
1 and 2. Okay. So this means that 1 mole of barium hydroxide reacts with 2 moles of nitric acid. So the molar ratio between the reactants tends to be 1:2. Okay. 1 mole of barium hydroxide reacts with 2 moles of nitric acid. Clear?
Yes, miss.
Okay. Yes, good, Zoya. 0.59 moles per decimeter cube is the right answer here. What are the answers for the rest of the students? Have you got the same? Ayla, Abdullah, Ishal?
Yes.
Okay. Rayan, did you solve it?
Yeah, Miss, but I didn't get that answer.
What answer did you got?
0.00000075.
How many zeros?
4.
Why? Tell me your steps.
Um,
What did you do first?
First of all, I did 0.15 times 12.8.
Times?
12.8.
So you multiply the concentration by the volume of the nitric acid.
Yes.
Why? If you need to find out the number of moles of barium hydroxide, you need to use the concentration of barium hydroxide, which is 0.15, and then you need to use the volume of barium hydroxide, which is 25.
Oh, okay.
Yes?
Okay.
N is equals to C into V, right?
Yes.
So you need to multiply concentration, which is 0.15 times volume, which is 25, and this need to be converted into the decimeter cube by dividing it by 1,000. Okay. Then you will be using this amount of moles to find out the amount of moles of nitric acid, since it is not given to you, only the volume is given to you, right? And you need to find out the concentration. So to find out the concentration of nitric acid, you must have the number of moles of nitric acid divided by the volume, which is already given to you, which is 12.83. Okay.
Okay, Miss.
All right. And how are you going to find out the number of moles of this? By using this molar ratio. If 1 moles produces 2 moles of this, so the amount of moles of barium hydroxide will produce how much moles of nitric acid, and then find out the final answer. Okay.
Wait, no, Miss, I still don't get what you do after you find.
After we find out the moles of barium hydroxide,
Yeah.
after you get the amount of moles of barium hydroxide, supposingly, let's just take a let's take a whole number or something to make things easy. Supposingly, I say that the amount of moles of barium hydroxide which is present is basically 3 moles. Okay, so I'm going to write X here. Okay, I will say that 1 moles of barium hydroxide, according to the stoichiometric equation, I will find out the molar ratio. According to my molar ratio, it says that 1 moles of barium hydroxide reacts with 2 moles of nitric acid. So if 3 moles of barium hydroxide are present, how much moles of nitric acid would have been reacted with it? Okay. And then I'm going to cross multiply this. This means that my X will be, the value for X will be 3 times 2, which is 6 moles. Okay. This means that this is the amount of moles of nitric acid which have reacted. So 6 divided by the volume. This volume is already given to you, which is 12.8 divided by 1,000. Since it is in centimeter cube, okay, you have to convert it into decimeter cube. And then you're going to find out this answer using your calculator, which is concentration is equals to moles divided by moles upon whatever the answer comes up is going to be in moles per decimeter cube, since you have converted centimeter cube volume into decimeter cube now. And the instructions, they particularly say that your answer must be to 2 decimal places, which means that you have to round it off to 2 decimal place. Okay.
Okay.
It is always a good way to write your final answers up to in 2 decimal places or up to 3 significant figures for whatever molar calculations or any other calculations you are doing in chemistry. Also, and look into the instructions which are given to you by the examiner. If the examiner gives you particular specific instructions, then follow up. Okay. Moving on to we did something about empirical formula and the molecular formula. And we just said that the empirical formula, that those formula which basically are the number of atoms which are given in a particular compound, but in their simplest whole number ratios. But the questions which usually come up in exam, they are where you are asked to find out the empirical formula of a certain substance and the components or the atoms which are present within the chemical compound, their masses or percentage composition by mass is given to you. For instance, if we say that you have hydrogen and oxygen which is given to you in a particular compound, okay, and the mass of hydrogen which is given to you is 10 grams, and the mass of oxygen which is given to you is 80 grams. Okay. So the first step is to find out, and you have to find out the empirical formula of this particular substance or particular compound. What are you going to do? The first step is to convert this mass into the number of moles. How? Mass upon mr is the number of moles. So mr, or the molar mass, basically. Molar mass is the relative atomic mass of the substance, which is 1, divided by oxygen's is 16, right? The final answer which comes up, the number of moles will become 10, and 80 divided by 16 is, yes, 80 divided by 16 is
5.
5. Okay. So we have two different numbers, two different number of moles of hydrogen and oxygen which are present in this particular compound. Now we are going to divide both of these numbers by the smallest out of these. Which one is the smallest number? 5 is the smallest number. So you divide both of these numbers by the number of moles by 5, and you get 2, and this is going to be 1. This means that the ratio of hydrogen to oxygen present in this compound is 2:1, and this is the simplified ratio, cannot be further simplified. Also, this is the simplest whole number ratio. Both of these numbers are in whole numbers. Supposingly, even after dividing the both these number of moles by the smallest number of these, gives you a decimal. The answer comes out to be in decimal. Supposingly it comes out to be 2 point, supposingly it comes out to be 1.5 and 2. Okay. Then what are you going to do? You will be multiplying both of these numbers by such a number to give you the answer in the whole number. Okay. So 2 times 1.5 is
3.
3. So you will write 3 here, and 2 times 2 is going to be 4. So this means that the whole number ratio will change to 4:3 if the answer comes only in decimal places. Okay. Is this point clear so far? So the empirical formula for this one is going to be H2O. This means 2:1 was the, since 2:1 was the answer. Look at another example. Supposingly I say that we have carbon, hydrogen, oxygen, and the percentage compositions are given to you. For carbon, it is 31.58. For hydrogen, it is 5.26. This is the percentage composition of this particular element which is present in this compound by mass. But oxygen's is not given to you. What will you be doing? You know that the whole compound is basically 100%. Okay. It is going to comprise and be completely be 100%. You subtract both of these two numbers, 31.58 and 5.26, from 100 to give you the answer for percentage composition for oxygen. Okay, what will be the answer here? 100 minus 31.58 and 5.26 gives you
63.16.
63.16. Now, when you know the percentage composition by mass, you will divide them by their relative atomic masses. For carbon, it is 12. It is given to you in the periodic table. For hydrogen, it is 1 to find out their number of moles. And for oxygen, it is 16. You will get the number of moles. And then what is the answer here?
It's 2.362.
2.362.
362.
362.
No, sorry, 632. My bad.
632. Okay, and what about oxygen? 63.16 divided by 16.
3.9475.
3.9475. Now, out of all of these, which one is the smallest number? Obviously, this 2.632, right? You will divide all of these by the smallest number, 2.632. Then the next one will also be divided by 2.632, and the next one will also be divided by 2.632. What is the answer you got?
1.9 for the first one.
1
9 for 5.26.
This will be 1. This will be
1.9.
1.9. That is approximately 2. And the next one? 3.95 divided by 2.63.
1.49.
Okay, so this is 1.5 basically. Okay, if you look into all of these numbers, one of them is the decimal place, and we want all of these ratios to be in their simplest whole number ratios. So even if one is not in one number is not in whole number ratio, so you in their whole numbers you need to multiply all of them by the such a number which is going to give you the simplest whole number ratio. So this is going to become 2, 4, and this tends to be 3. So the empirical formula will become C2H4O3. Okay. Is this point clear so far?
Miss, I just have a question. Why did you multiply them by 2?
To give us the whole number, no? Empirical, the definition of empirical formula is that all the atoms must be in their simplest whole number ratios. 1.5 is not the whole number, right? We need to convert this into whole number. So to convert it into a whole number, we need to multiply it by such a number to give you the simplified whole number ratio. So obviously, if you multiply it by 1, obviously you will get 1.5 again. So you need to multiply it by 2 to give you a number. But even if by multiplying it by 2, supposingly I don't get a whole number, then I should be looking onto another successive number. Okay.
Okay, Miss.
Okay, and since you're multiplying this one as well by 2, so you have to multiply rest of the ratios by 2 as well. Okay, you have to multiply 1 by 2 as well, this 2 by 2 as well to give you the simplified whole number ratio for all of the elements which are present in this compound. Are we clear?
Yes, Miss.
Okay. All right, I'm ending the session till here for now. Tomorrow we will continue with molecular formulas and some of the related questions. A bit of the topic is still left. And then inshallah, we are going to move on to a new topic. All right, do we have any questions from today's class? Ayla, Ishal, Basit, Rayan, Doya, Fahad, Ahmed, no questions? All right, everything's clear?
Yes, Miss.
Yes.
All right, take care, Allah Hafiz, then. Thank you.
Allah Hafiz, Miss.
Allah
Thank
Hafiz,
you.
Allah Hafiz,
Allah Hafiz.
Allah Hafiz,
Love.
Allah Hafiz.